We say that two lines are parallel if they are coplanar and do not intersect. Now, just because you see two lines doesn't mean that they're parallel. So generally speaking, if we see two lines and they have a symbol like this on each of them, that means that they're parallel. Or it might have a couple of them. That means that they're parallel. We say then the symbol for parallel is also this. So for example, if I have line L and I have line K, we say that line L is parallel to line K. And then of course we'd have little symbols in here to show that they are parallel. Problem 1, the parallel postulate. Now this is not how it was originally stated by the mathematician Euclid. This is a more modern presentation of the parallel postulate, but the idea is this. If I have a line L, and there's a point P not on line L, there's exactly only one line that I can draw through point P that's parallel to line L. Exactly one, and that's it. So it kind of forces us, and you may have seen that already in the simulations that we did. If I have two parallel lines and I cut them with another line, and it intersects both of them at two different points, this line is called a transversal. We usually denote that with a lowercase t. So for problem 2, let's go ahead and draw two parallel lines. Here's line L and here's line K. And we'll denote their parallel by putting the little arrows on there. And let's cut both of them with the same line. We'll call that transversal T. It cuts it right here, intersects line L at that point, and line K at that point. Next, let's go ahead and label the 8 angles. So there's an angle right here. 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 angles that were formed because the transversal cut through those two parallel lines. These two angles are called corresponding angles. These are corresponding angles. These are corresponding angles. And these are corresponding angles. So if we focus, there's a total of 4 pairs of corresponding angles. If we were to focus, for example, on 1 and 5, then 1 and 5, angles 1 and angle 5 would be corresponding angles, as an example. That's one pair. Note that from our appearance of it, angle 1 seems to be an acute angle, and angle 5 also seems to be an acute angle. That would mean that these are congruent or equal to each other. So any pairs of corresponding angles, each of those angles are congruent to each other. Now don't be fooled. It doesn't mean all corresponding angles are congruent. That's not true, because we know, for example, that angle 2 and angle 6 is another pair of corresponding angles. So for example, angle 2 and angle 6, well, those are congruent to each other. Those are equal to each other. You'll note that they look obtuse, right? So here's angle 2 and here's angle 6. Both of them look obtuse. So angle 2 is equal to angle 6. It's congruent to angle 6. However, angle 1 and angle 5 are also corresponding angles. Those are congruent or equal to each other. But don't confuse, don't say that all corresponding angles are equal to each other, because that is false. Okay? We're saying that pairs of corresponding angles are equal or congruent to each other. So for example, if we're looking at angle 1, angle 5, we can clearly say that they're equal to each other. Or if we're looking at angle 2 and angle 6 only, we can say that they are equal to each other. Next, let's talk about the exterior. So you'll note that we have these two parallel lines, and you can either be in between the tracks or you can be outside of the tracks. And so if you're on the outside of the train tracks, this is known as the exterior region. So angles 1, 2, 8, and 7 are in the exterior region. There's also alternate sides. So there's this yellow side of the transversal, and then there's that reddish side of the other side of the transversal. So we have alternate sides. So these are what we call alternate exterior angles. And here's the other set of alternate exterior angles. Note that they're on the exterior, right? They're on the outside of the parallel lines. And alternate means they switch off. So for example, if we look at these two angles, these are alternate exterior angles. There's only two pairs of them. And again, if we look at this carefully, it looks like angle 1 is acute, and angle 7 looks also acute. If you turn your paper upside down, you'll notice that. And so we can say that alternate exterior angles are congruent or equal to each other. But once again, do not say that all alternate exterior angles are congruent. It's only pairs of alternate exterior angles are congruent. So we could say, for example, that angle 1 is congruent to angle 7, and we can say that angle 2 is congruent or equal to angle A. But we can't say that they're all equal to each other. We now focus on alternate interior angles, and interior means we're between the two parallel lines. So here's a pair of alternate interior angles, and here is the other pair. So there's two pairs. Let's consider angle 4 and angle 6 for our example, our sample pair. You'll note that angle 4 is obtuse, and angle 6 also looks obtuse. So it's pretty safe to say that these are going to be congruent to each other. And once again, we're not saying that all alternate interior angles are congruent to each other. We're just saying that each pair is congruent to each other. Consecutive interior angles are again in the inside or the interior, but instead of alternate this time, they're consecutive, which means that they live on the same block. They didn't cross any streets, they live on the same block. So for example, angles 4 and 5 are consecutive interior angles. They live on the same block in between the two parallel lines. And we also say that angles 3 and 6 are consecutive interior angles. Again, they're interior and they live on the same block in the same neighborhood. So if we look at angle 4 and 5, for example, you'll note that angle 5 looks to be acute. And if you're not sure what that means, you're going to want to go back to your notes on angles. Acute means an angle less than 90 degrees. Whereas angle 4 looks like an obtuse angle, which means it's more than 90 degrees. And so we can't say that they're equal to each other. We can't say that they're congruent to each other. However, we note that acute plus obtuse could never be 90 degrees. So may I propose to you that an acute angle plus an obtuse angle could possibly be 180 degrees. And I would propose further to you that consecutive interior angles are supplementary. In the same manner, we would say angle 3 and angle 6 are consecutive interior angles, and they are also supplementary, which means that if you add up the measurements of their angles, it would equal 180 degrees. Finally, by way of review, we've talked about vertical angles quite a bit in this class already, but just in case, vertical angles are going to be angles that are across from each other, and then there's a point in between. So for example, angles 1 and 3 are vertical angles, or angles 2 and 4 are vertical angles. 5 and 7 are vertical angles, 6 and 8 are vertical angles. We've done enough work with these for you to know that vertical angles are congruent, or they're equal to each other. And as a sample pair, we have angle 1 and angle 3 as a pair of vertical angles, and they're both equal to each other. There's a total of 4 pairs in this diagram. Finally, linear pairs, which we've also discussed before. A linear pair are two angles that are adjacent, which means they're touching, and supplementary. So for example, angle 1 and angle 2, those two angles form a linear pair. You'll note that they actually form a line, and they're touching, sharing a vertex. So angle 1 and angle 2 are a linear pair. 2 and 3 are a linear pair. 3 and 4 form a linear pair. 1 and 4 form a linear pair. Also, 5 and 6 form a linear pair, 6 and 7 form a linear pair, 7 and 8 form a linear pair, and 8 and 5 form a linear pair, for a total of 8 linear pairs. In this case, let's count angle 1 and 2 as our sample pair. We should know at this point, based on the linear pair postulate, that linear pairs are supplementary. So we know that whatever angle 1 and angle 2 are, they're going to go ahead and add up to 180 degrees. For your summary, looking at the table that we just filled out, are any angle pairs from above equal to 90 degrees? Which angle pairs from above are equal to 180 degrees? Take some time to think about that.